So I have my friend Paul Beckwith with me. Paul is in frosty Ottawa. Is that right?
Yes.
Ottawa, yes. Paul, very quickly, just give us a quick background on who you are and what your credentials are to be talking about these things.
I'm a climate systems scientist. I often teach at the University of Ottawa, sometimes at Carleton University, both in Ottawa. I've taught mostly climatology, introductory climatology courses, and then some more advanced courses on things like oceanography, earth sciences, weather prediction, some other geography courses, in mostly at University of Ottawa,
Okay.
and then an introductory sort of physical geography course at Carleton. And I am an engineer. I have an engineering physics degree, master's degree in laser physics. Worked in high tech for many, many years. But I've been doing climate stuff for quite a while. My principal role is to try to understand, how all the different parts of the climate system are working and what's happening now, what's happened in the past, what we can tell about projections on climate changes in the future. So I try to educate people via mostly via a YouTube channel, website.
Yeah.
I often give talks, community talks, public talks, talks at scientific conferences. I've attended, I guess, six of the global climate conferences, the COPs, over the years, starting in Lima, Peru in 2014. I was at the Paris Climate Conference, the big one in 2015. Just most recently was in Baku, Azerbaijan a few months ago for
Yep. Yep.
COP29. So I've been very active in the climate community for many years,
Yeah.
and I have literally thousands of YouTube videos trying to educate people on what's going on with climate change.
Yeah, great. And you're actually my tutor in climate change because I've been watching your YouTube videos for years and I love them. And you weren't at COP28 because had you been at COP28, I was going to take you for a drink at the Skyview Bar at the Burj Al Arab, but you weren't there. So
Yes, I missed that one. I was at the one before that in Sharm el Sheikh, Egypt, and
yeah,
and
yeah,
at the one after, like I say, in Baku,
yeah.
Azerbaijan. But
Are
I
you
I
going to be
missed
in
that.
Belém for COP30?
I'm hoping to go to Belém, but it's a bit, it's dependent on getting the badges to get in,
Yeah.
which, but also, I mean, the biggest factor in Belém is they're lacking sufficient accommodation at the moment.
Oh,
So the
okay.
prices of accommodation are sky high.
Oh, really?
But
Okay.
the government is supposed to be stepping up and opening up public schools and army barracks and perhaps even renting some cruise ships to have people
Now we're
stay in the
talking.
rooms in a
Yeah,
ship. I mean,
yeah,
they picked a place where there's not enough accommodation
yeah.
at the
Right,
moment.
right, right. So, I mean, I was hoping to get myself there, and what I discovered was 130 kilometers from Belém. There's a place where you can swim with river dolphins.
Oh,
Yeah.
okay.
So there's that.
So maybe yes, you can bring one of them to the conference in a big,
Okay, so
water tanker or something. Yeah.
yeah. Anyway, I think we've got the right guy to be talking about the climate aspects of Cyclone Albert. I learned today that in the naming system of these cyclones, they go, A, B, C, D, and so forth. This one I heard was supposed to be called Cyclone Anthony, right? But because the
Okay.
Prime Minister is called Anthony, right? They didn't want to shine the light on the fact that this guy is
Right.
constantly opening fossil fuel production facilities, and so they decided to
Okay.
call it Alfred. So how's that, huh? Hey, just
Okay.
another thing.
Well, I wasn't there a cyclone recently that started with a Z?
Uh,
Like I thought maybe I thought in
oh yeah,
in the north
Zelia,
of the,
Zelia,
yeah.
in Western Australia.
Yeah, so what happened with that one? They're starting at Z and working their way to A or in
Oh
a
no, no,
different
they got
region?
to Z, and then they kind of went back to the beginning again.
Oh, okay, they had to start again. But
Yeah.
doesn't it renew every year? Like every year you start at A, or I don't know the naming system. I think it's upside down in Australia. I think maybe you start at Z and work your way to A or
That's a,
something.
that's a cheap joke there, Paul. Hey, I just want to make a point. See there where it says more coal and
Yes,
gas?
more coal.
I just
No,
it actually
I
says
can see
no.
it's a yes, that's better. Okay. Thank you.
I'm
Yeah,
a
you got to
fan.
get the top of that poster invisible, otherwise you're in trouble, right?
I'm a plant from the fossil fuel industry.
Yeah, I'll have to stop talking with you if the poster if the no isn't included in the poster.
Okay,
So, are you worried about this, like hitting your house, taking your roof off? You know,
so
it's what
I'm
it's
saying,
category 2 at the moment, right?
yeah, high end category two, and they're talking that it could potentially go
Go
into
to 3.
three.
Week
Uh,
3. Yeah, it's about 150 kilometers an hour winds,
yeah,
sustained winds,
yeah, yeah.
which puts it, yeah, it's right at the border, category
So
2 to 3.
so in Australia, apparently there's a different rating scale for. Let me just check that because I've got this on ChatGPT. So there's the Saffir-Simpson scale, which is normally,
Yes.
but then there is the Australian cyclone category system, which puts a category two. So in Saffir-Simpson, a cat two is 154 to 177 kilometers an hour, or 90 to
Okay.
110 miles per hour.
Right.
The
Right.
Australian system, a cat two is 89 to 117, 55,
Huh.
3 miles per hour. So I don't know why they do that.
Yeah.
It's really
Okay.
complicated. Uh,
Well, they can make the storms sound bigger than they
yeah.
are, I guess.
But I think
I don't know.
150
Um,
kilometers an hour seems to be a number that
yeah.
we're talking about, right? Um,
Yeah, it's 150. I think what's so significant is, I mean, this is a very unusual storm for Brisbane, right?
yeah,
Because
yeah,
normally they stay they don't get so far south,
that's
right?
right.
Because the water they need the warm water temperature
Yeah,
to maintain strength. It has to be 26.5 degrees Celsius, which is interesting because I think that waters off your coast normally would be about 26 degrees, which isn't sufficient to amplify the storms. But because it's 1 degree Celsius warmer than normal, it's 27, which pushes it over the threshold to amplify storms. And also another really big factor is that there's very low wind shear. And what wind shear is it's changes in the wind speed and direction with altitude. So if the wind is blowing, say, west to east at the surface, and then, south to north at higher altitude, that tends to it tends to reduce the organization of the storm system and therefore weaken it. In extreme cases, it can basically knock the top off the storm
right.
and
Yeah,
and kind of neutralize it. So because the wind shear is very, very low, plus the water temperature is very, very high,
yeah.
and I don't think the storm is moving very quickly through the water. So if
10,
it's
10
moving too
kilometers an hour.
fast,
10 kilometers.
pardon me? Yeah, 10 kilometers. So if it was moving slower, it could self-quench as it uses up all the warm water at the surface.
Right.
And if it was faster, it might not get the amplification from all of the warm water. So it's in a kind of a sweet
Right.
spot
Right.
for
Right.
speed. And they're expecting perhaps you might get as much as 700 or 800 millimeters of rainfall
Yeah.
from this storm. So there could be flooding just from the rainfall. Of course, depending on the angle it hits the coastline, you're going to get some storm surge.
Yeah.
And then, of course, you can get wind damage on
Yeah.
structures from that sort of thing. So it could be a very significant storm
Well,
for
so
Brisbane, and you don't normally get them. So,
let me share a few things. So the last time in fact, I think the only time in the recorded history that a cyclone eye came across the coast of southeast Queensland was in 1974, and it came across in Coolangatta, which is right on the border with New South Wales. So that's
right.
50 years ago, and
Hmm.
and this one is basically it's been going on for like over 10 days or something. and it's drifting
Right.
up the coast, way out to sea, 700 kilometers out to sea, parallel down the coast. But in the last 4 days, or last 2 or 3 days, it's just done this 90-degree turn and is
Mm.
barreling straight in towards the capital, where there's around four.
Yeah, yeah, it's funny. So, I mean, it often does these meanders, but it's also there's also upper level winds,
Yeah,
that can guide these storms, like
yeah,
the jet stream activity. I
yeah,
mean, I really like the if people watching this, they should stop the video and watch and open up search for Earth Null School and open that
yeah,
application, click on Earth, the icon for Earth, and then you can set the different parameters, look at wind speeds at different heights, pressures, and then you can play like a movie if you like and see the motion of the storm and where it's projected to move
yeah,
and so on. So
yeah,
I mean, it's pretty clear. I think it's going to hit Brisbane pretty much. The eye will pretty much go over from what I can see,
yeah.
unless unless there's a big change in the next day or so.
Well, it's been really consistent over. I've been following it every 6 hours. The BOM does an upgrade of a diagram which shows like a little line, which is the moon
Right.
sky,
Okay.
and that's moved up and down by about 30 kilometers. It's wibbled and wobbled around that range, but all
Right.
up and down north and south of Brisbane Central Business District, which is about 2 kilometers away. So it's quite possible
Right.
we'll be going through the eye. On the subject of the eye, it looks
Mm.
really, really indistinct, the actual satellite images. So the Himawari 8 Japanese weather satellite is got a
Yes.
live feed of the storm, um,
Mm.
as well as the Discover Epic. So Discover satellite, which is
Okay.
Al Gore satellite at 1.5 million kilometers
Yes.
at L1.
Mm.
That's also got the storm on it. But
Okay.
in the previous photos that I've been looking at, the eye was not distinct, so it was all just covered. So is that what's that about? Why would the eye not be distinct?
Well, you can get I mean, there's a lot of factors that go into it. I mean, on Earth Null School, it looks pretty symmetric, the storm, and it looks pretty,
Hmm.
well formed. But you can get eye replacement occurring as the storm intensifies. That's not occurring now. I mean, it's pretty much a stable intensity. It looks like maybe slight intensification, but the eye wall can sometimes go less distinct and then reform and become more distinct and so on. It's
Right.
part of the life cycle of these storms. Depends a lot on what's happening at sea level, what the ocean temperatures are, how deep down you go in the water column and have warm water. Because of course, if you've got that 26.5 degree or higher water temperature going down, several hundred meters, and that
Right.
energy can be
Yeah.
extracted for the storm. So there's a lot of different factors, the
Yeah.
storm speed. And again, shear, there could be some low level shear.
Right.
It's not zero, it's very low. So the storm is not getting weaker, but it can do things with the eye. So and of course, in the northern hemisphere, in the Atlantic basin, for these hurricanes, especially ones that threaten the U.S., NOAA has these hurricane hunter aircraft.
Right. Yeah.
Now, I haven't heard if those aircraft are being cut at the present. I mean, lots of NOAA is being reduced, lots of layoffs,
Yeah.
lots of scientists losing their jobs that are doing climate research and climate monitoring. The words climate change taken off websites and so on. So I don't know. I mean, the hurricane hunters are part of the National Weather Service, which does a lot of the forecasting and tracking for hurricanes. I mean, cyclones are the same thing,
Yeah.
right? It's just called a cyclone
Yeah.
instead of a hurricane.
Yeah.
Some parts, near, India, et cetera, they call them typhoons,
Yeah.
right? They're all tropical storms,
Yeah. Yeah.
the same beasts. Although they're spinning differently, they're spinning the other direction in the
Yes.
southern
Yeah.
hemisphere, of course.
Yeah, so that's a good point. So on that for a moment, so if we were to look from space at this thing, it's rotating the winds, the strong winds close to the eye are rotating clockwise, and
Right.
as the in this instance the storm is heading towards the west, which means that it's got, say, let's say, for example, hypothetically, just for simple numbers,
Yeah.
right? Let's
Hmm.
say the wind speed is 100 kilometers an hour, right? The storm is traveling west at 10 kilometers an hour, which means if
Right.
you're on the ground on the southern eye wall, you're going to be
Yes.
experiencing 110 kilometer an hour winds, and on the
Right.
northern sky wall, 90 kilometer an hour winds, right?
Yes, yes, that's correct. And the rotation, the spinning is of course due to the Coriolis
Yeah,
effect,
yeah,
which is because everything's occurring on a spinning Earth.
yeah,
And the Coriolis force is it's zero at the equator.
yeah,
So this is why when you look at if you look at look at a map of all of the storms
right.
in both hemispheres,
Yeah,
you don't see any of them appearing, within plus or minus say 10 degrees of the equator
right.
because they don't
Spin
get the
zones.
rotation triggered when they're right near the equator because the Coriolis force drops to zero. So,
Yeah,
Coriolis force is maximum at the poles and minimum zero at the equator, up to about 10 degrees latitude north and south of the equator. It's basically you don't get these storms triggering and forming
yeah.
at all. So that explains. So it's interesting the differences that you see. But I mean, Australia is it's not a densely populated country, right? I mean, at all. Like there's just
Australia isn't, but Brisbane is.
yes, that's right. So it's just really bad luck that this
Yeah,
thing's coming along, and it doesn't happen very often. You mentioned the 1974
yeah,
storm,
yeah.
and I think there's been some since then, but much smaller storms. Like I think, but you've had some major cyclones, hitting the country. I mean, I read about Cyclone Yasi in 2011
Yeah, yeah, yeah,
which was 280-kilometer an hour winds.
yeah. Well, that again,
So
these are normally
yeah,
like that's something for North Queensland to worry about, you know?
yeah, exactly. North Queensland and
Yeah,
very low population density, so low impact on people.
yeah.
Um, but
Um, so Paul, just back to that idea that we've got stronger winds on the southern part of the eye wall and weaker winds on the north. Okay, but the power in the wind is proportional to the cube of the wind speed, right?
yes, yes, that's correct.
So I don't have my calculator here, but if you've got 110 kilometers an hour winds south and 90 kilometers an hour winds north, if you apply that cube rule, that could mean that
Yes,
actually that the winds are twice as damaging south as north.
the wind. Yes, it can be. The cube. So you take the ratio and cube it, you can get the factor of difference. Yeah, yeah. Wind damage is highly nonlinear. So
Hmm.
this storm, when I mean, parts of Brisbane could get 150-kilometer-hour winds. So that means 160 on one eye wall and 140
Yeah,
on the other eye
yeah,
wall. And
yeah,
then if
yeah,
you and there's a very strong threshold for wind damage, where if the wind is below a certain number, there's almost no wind damage. Maybe some shingles on roofs. Depends on how strong the structures are built. I assume most are wooden structures. With asphalt shingles for roofs, or do
no.
people have metal roofs, or do you use wood
Not
slats, or
over here.
I don't know.
You'll have tiles or sheet
Yes,
tin.
tin.
Yeah,
Yeah, yeah. So that can be yeah. So the threshold for damage is highly nonlinear. There's a
yeah,
threshold. If you're below the threshold, everything's fine. You get a couple lawn chairs knocked over in your backyard. If you're above a certain level just by a few kilometers an hour, then the you can get catastrophic damage,
yeah, yeah, yeah,
wind damage to structures. So, I
yeah.
guess are people taking this seriously? Or they talk? I guess everybody's talking about it in Brisbane, but are
Everybody
they?
is
It's so
taking it. Everyone's taking it very seriously. I mean, this is effectively never happened before. Technically,
right.
so
Okay.
here's the other thing as well. I was talking to a friend of
So,
mine.
like, are the grocery store shelves empty?
Yeah, yeah.
I mean, they're empty in Canada, at least the section for U.S. goods, but that's for a different reason, right? they're taking U.S. goods off the shelves, and
different types of hurricanes.
they completely cleaned out the any Jack Daniels, any U.S. liquor has disappeared, completely vanished.
We don't have it, so
So, but this is not a this is Cyclone Trump. This is not
yeah, no, I get it.
Cyclone, your cyclone. So,
Yeah. Yeah, so I was talking to a friend of mine. So it's not uncommon for us for this part of the world to get the tail end, so extra tropical cyclones. So once a cyclone
right.
stops spinning, it's just got this massive body,
Massive, mostly rain and a bit of wind.
mostly rain and
Yep.
the wind. Exactly. They're not uncommon, right? And I was talking to my friend who's a builder the other day, and he said, oh, I'm not really worried about this cyclone. I said, buddy, you're not getting the point. This is coming, the eye's coming across
Yeah.
the city,
Yeah. Yeah.
right?
Is this guy's name isn't Bob by any chance, is he? Bob the Builder, the
Yeah,
that
yeah.
my kids love Bob the Builder,
I
right?
get
So
your
sorry,
point.
I haven't been into any alcohol. I can vouch for that tonight, but it's just
Well, maybe you
you know
should.
maybe I should, yeah. So he's not worried, but now we'll take another look at it because
Well,
you're
now he's
telling him
worried because I said it's the wind, the rain's coming in horizontally, and he's like, oh, okay, horizontal, that's different. The houses aren't. So what I'm saying is that the houses
yeah,
of this part of the world aren't built for
for this type of
cyclones come
thing.
over.
Yeah,
Yeah.
right.
So there's that. So Paul, this is the important part that I really wanted to get to is that as the humans continue to belch 50 billion tons a year of heat trapping gas into the atmosphere, there's around 2 trillion tons of excess carbon dioxide in the system, to my understanding, which is
Hmm.
which is creating this increased heating. The planet's getting hotter. Um, climate change and global warming, how is that affecting tropical revolving storms and how does that influence what we're seeing here with Cyclone uh, Alfred?
Well, one of your meteorologists has done a study, I believe, on the frequency of occurrence of these cyclones, and he's found that with the warming, there's actually something like a 13% reduction in the number of cyclones
Yeah,
that you're seeing. But he's also found that the cyclones that do form are stronger and larger,
yeah,
and and a large part of this is again due to the increase in the sea surface temperature,
yeah,
because that's a very strong threshold effect. I mean, if you're at 26 Celsius, the storm goes through, it's not going to intensify.
yeah,
If you're at 26 and a half or above, then it intensifies. If you're at 27, if you're at 28 versus 27, there's a huge difference. There's so much more energy in the ocean that can feed into the storm, increasing the intensity of the storm.
yeah,
And it's especially noticeable in the in the Atlantic region, the Gulf of Mexico / America. The water temperature can be so warm in those regions that, you can get a tropical storm forming and traveling along, and it hits the warmer water, and then it can go all the way up through the categories and essentially be a category 5 within 24 hours or so. Like, it's just phenomenal
yeah,
explosive growth. And then the next day it hits Florida, for example, with very, very little advance notice. So it depends on, the water is really the key for these storms. So, climate change, of course, has given us record warm temperatures globally in 2023 and also in 2024. So we passed the 1.5 Celsius sort of number that people talk about, the threshold, if you like, and we're into pretty serious climate change. James Hansen's done a lot of work on the rate of temperature rise, and from 1970 to about 2010, global average temperature rose 0.18 degrees Celsius per decade. And since 2010, it's been rising at 0.36 degrees Celsius per decade, which is at double the rate. 2025, the record temperatures in 2023, 2024 it was actually as much as 0.4 degrees Celsius warmer than any previous years. About half of that is due to what he argues is a reduction of sulfur in shipping fuels
Yeah.
for commercial ships. And that means with less sulfur, there's fewer low level clouds and the fewer aerosols in the ocean, in the air above the ocean. And these aerosols, when they're there, they reflect sunlight, is a direct effect, but an even larger effect is they act as cloud condensation nuclei to form low level clouds, which then block sunlight, reflect a lot of sunlight back up, and cool the surface below. So Hansen figures that that's about a zero point 0.2 degrees Celsius effect, and the other 0.2 is a weak El Nino that was occurring. So that El Nino has passed, its sort of neutral state. So that would knock zero point 0.2 off. So we might end up, he doubts that 2025 will be a record global temperature, a record year for global temperatures, but he thinks it will be pretty close. It'll be right up there.
Yeah.
And the other big factor with climate, we talk about the emissions all the time, but a big factor is, what happens to these greenhouse gases when they're in the atmosphere. So CO2, of course, a lot of it is absorbed with it follows a cyclical pattern. It's like a wave which goes up and then dips
Yeah.
down and then goes up. And you've probably seen the zigzag pattern. And that dip is about 7 parts per million, or it used to be. And that's due to the vegetation coming alive in the
Right.
northern
Okay.
hemisphere or boreal summer.
Yeah.
But a recent paper shows that the dip, the natural absorption of CO2 from the atmosphere from the biosphere, plants particularly growing on land in the northern hemisphere, has actually been weakening. So we reached a maximum CO2 absorption in 2008. Since then, it's been dropping. There's been less CO2 being taken up by plant. So basically, some of the carbon sinks on the planet, the major ones they're reducing in strength. And that combined with the increasing emissions brings us to very much higher greenhouse gas levels, much higher warming. And there's another big factor that's very important for the Southern Hemisphere and Australia, and other nations in the Southern Hemisphere is the ocean currents, the AMOC stands for the Atlantic Meridional Overturning Circulation, and that's slowing down. So what that means is it's bringing less heat. Think of the Gulf Stream crossing the Atlantic, going up and bringing all this heat to Western Europe, right? Like the latitude of Western European cities is on par with that of Northern Canadian cities, where it's way, way colder. In Canada, the heat that comes across from the Gulf Stream over to Europe brings very, very decent mild temperatures to Western Europe. So that current is slowing. And there's a lot of scientific research on how much is it slowing? Is it going to shut off? But it's definitely slowing. And because it's slowing, there's less heat coming from the tropics, the northern hemisphere. So the tropics are warming more
Right.
quickly,
Yeah.
and there's more heat going into the southern hemisphere down to you guys in Australia.
So the slowdown of the AMOC is increasing the average temperatures in the southern hemisphere.
Yes, exactly. And it's having a number of different effects. One of the major effects is the sea ice around Antarctica was increasing about 1.5% per decade, and that continued for many decades and halted in about 2015. Since 2015, we've had a huge decline of sea ice around Antarctica, and it's believed that it's the water is warmer. The southern hemisphere is warming. That warm water is undercutting, getting underneath the ice shelves, et cetera, causing increased melt, slowing down the circulation, the southern annular mode circulation, which circles Antarctica, right? There's no land to impede it. So these are
Yeah.
very strong wind patterns and very strong ocean currents that kind of isolate Antarctica and keep it cold. Well, they're weakening. We're getting warm water going closer to Antarctica, causing the complete collapse of sea ice essentially,
Mm.
and more melt.
Which
But
which
also
reduces
it's
which reduces albedo, which
right,
then more
right. But
heat,
it's
so it's
also
positive feedback.
it's also a reason why, suddenly the water temperatures are much warmer down around Australia, and the warm water is going further south than it did before.
Yeah, yeah,
So this is why, you're going to start getting these rare storms. They won't be so rare if the water temperature is
yeah,
maintained at such high levels.
yeah,
So there's a huge, you need to look at the overall climate system to
yeah,
kind of figure out these different connections and components, which is what I've been trying to do for years.
yeah, yeah. So you're familiar with Hurricane Otis from October 2023 that took out Acapulco?
Yes,
So this is the question that I've got, right? So my understanding of Hurricane Otis, it was quite extraordinary because the water was so warm that this thing showed up as a tropical low, and within 24 hours, it was a Category 5 hurricane, and that just
right.
broadside a city of 1 million people, and
Yes.
just totally wrecked it. There's you can see photographs of it. It's just like ruined the city.
Yeah.
So this
Mm,
is my question, Paul, is
yeah.
if we keep allowing our politicians to collude with industry and we keep building 50 billion tons of CO2 in the atmosphere, how long is it going to be before the sea temperatures and the conditions are right for a Hurricane Otis to happen in Brisbane, which is to say that we don't have a week to prepare for a Category 2, we've got 24 hours
Right.
to prepare for a Category
Mm.
5.
Yeah, I mean the rapid intensification is becoming a huge issue because people need time to they're given warnings. There's a storm out there, it could affect us, and then a few days later, well, yeah, it's heading towards us. A few days after that, okay, hunker down, take preparations. I mean, if the thing intensifies so quickly, you lose that window. So the authorities have to start preparing themselves to have better warning systems that can operate quickly. And you know the 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 problem the problem is like these James Hansen calls them superstorms.
Mm.
And he's written a book. He wrote a book a decade ago called "Superstorms of Your Grandchildren."
Storms of my grandchildren.
Yeah, storm. Yes,
Yeah,
yeah. Basically, storms for my grandchildren.
yeah.
And he talks about these superstorms, and this is the sort of thing that he's been talking about. For every degree Celsius rise in air temperature, the air can hold about 7%
Yeah.
more water vapor.
Yeah.
And when it holds that much more water vapor, as that water vapor, which is a gas, as it rises higher, it cools down and condenses into water droplets, and that phase change from the gas to the liquid releases huge amounts of energy, which acts as rocket fuel for these storms to intensify and amplify.
Yeah. Yeah.
Okay. So, and you can actually get the effect is even larger if you look at, rainfall, because according to your Australian meteorologist guy, um, he was saying that he expects in the future about 15% more intense rainfall for a 1 degree Celsius increase in warming, 7% more water vapor, humidity in the atmosphere, and he expects that will translate into 15% more intensity in rainstorms and rainfall amounts. I mean, this is a category 2 that's coming to you, and even this is expected to perhaps rain up, 700 millimeters or 800 millimeters. So, almost like a meter,
Yeah.
which is a meter's 3.3 feet. So, 2.5 feet of rain.
Yeah.
And if you add all that water, it's got to go somewhere. It goes to the lowest points. Um,
So,
and
Paul,
combine it with a storm surge if you're on the coast. And the winds, I mean, it can be a pretty horrifying event.
yeah.
And it's sort of out of the norm. So people, one of the problems is as the southern hemisphere is warming, you're going to get more you're going to get warmer water going to more southerly regions. I mean, you've had massive storms. Like I mentioned, Cyclone Yasi in 2011,
Yeah, yeah,
right? 280 an hour winds in Queensland. You know,
yeah,
that's north of you.
yeah,
But what happens if the water conditions are much warmer where
yeah.
you are? And then, I mean, what if it was a 280 an hour storm? You guys would all be hightailing it to high ground, getting out
But
of the
and
city, leaving
and
Dodge, you
and
know?
back to my question, Paul. How long
Yeah.
before? I'm not trying to be
Okay, well,
melodramatic
how
here.
long? Well, okay, I
Right?
mean, if okay, so
Before we get an Otis conditions,
okay, so
Brisbane.
if the temperature, I mean, the temperature rise has accelerated. I say it's doubled since 2010. The
Yeah,
temperature rise per decade. That's
yeah,
global average temperature. The poles are warming much faster, so the Arctic is warming at least 4 times faster than the global average. If you go to higher latitudes in the Arctic, it's 5 to 7 times warmer. The Antarctic's warming about double the rate it was just not a few decades ago, basically. So the warming's accelerating there. But it depends on the other elements of the climate system. So it depends on the tipping point. So some people are arguing that the AMOC could actually shut down in, say, 2 or 3 decades. So if the AMOC was to shut down in 2 or 3 decades, the Arctic would start getting colder again, but the tropics would greatly warm and the southern hemisphere would greatly warm. Melt rates would greatly increase in Antarctica. So the reduced melt rates of Greenland would be more than compensated by the increased melt rates in Antarctica, mostly the western Antarctic ice sheet, which is ice grounded on bedrock well below sea level. So warming water contributes to that melt bigger than air temperature rise. So you could be talking about a lot of and there's also studies showing the weakening of the air circulation and ocean current circulation around Antarctica. So if that is part of the AMOC slowdown related to it, then you could see a huge, rapid, abrupt increase of water temperatures further south. And then you could start getting those storms in. So if the AMOC was to fail, it could be 2 or 3 decades off when you start getting these massive storms much further south. But
yeah,
there's a lot of speculation, right? I mean, we don't really know. And there's a study came out a few months ago, and it said, "Oh, don't worry about the AMOC. It's more stable than people think." You know, this was a peer-reviewed paper, but the previous 10 papers said it was flowing and failing
yeah,
and
yeah,
in risk of stopping. So, you know, the most recent one said, well, we think that the other 10 are wrong. So this is how science advances and works,
yeah,
right? People,
yeah,
do their studies and publish their results. So the jury's still out on that. So, but we're really playing with fire. I mean, if you stick your hand into the fire, you can pull it out really quickly and not have severe burns, right? But if you leave it in a bit too long, you get burned. So this is what we're doing to our planetary systems,
yeah,
our oceans, our atmosphere, by just with this huge pulse surge of greenhouse gases.
yeah. So I've got this little statement that I make frequently, but I've never actually had the chance to run it past a climate scientist, right? So can I just
Yeah,
share my statement and you give me your thoughts on it, right? So, I'm not in the game of being an alarmist or a disaster theorist, right? But I'm also just trying to accurately convey what I understand to be the state of the science, right?
yeah.
Because if we continue to grow the global economy based on fossil fuels, we risk triggering a cascade of climate tipping points that could force the collapse of human civilization and the extinction of most life on Earth.
Yeah, yeah. So I mean, there's many people that are talking this way and thinking this way, and there's a lot of geopolitical uncertainty. Not just from climate, but I mean, climate has its finger on so many different factors, right? Like the ability to grow food, the ability to get fresh water, and these storms are happening. The frequency of these extreme weather event, these storms, the severity of these storms, the duration of them, is all worsening rapidly, right? I mean, I call it weather wilding, weather weirding, and weather whiplashing. I mean, the whiplashing is interesting. We can go from like a heat wave in a region to a very severe cold, and then back to a heat wave in a matter of weeks, right? So this whiplashing, we can go from a couple of years in a row where there's almost no rainfall in parts of the US, so the Mississippi River is at record low levels, and the US Army Corps of Engineers has to go and dredge in order to keep the shipping going in the Mississippi. And then a few years later, there can be torrential rains, and then the river's flowing at record high rates. And then a few years after that, it's back to record low rates, even lower than the previous record. So
Yeah.
this is like a whiplashing, from one extreme to another extreme. I mean, the biggest component of all of these things is, of course, the changing jet stream patterns, because as the Arctic warms much, much faster than the equator, it lowers the temperature gradient or difference to the equator. And it's a temperature gradient that causes the jet streams to be, if the gradient's high, the jet streams move quickly. And if they're moving quickly, they're moving mostly zonally, which is from west to east. And the waves in the north-south direction, the meridional direction, are minimal. But as the Arctic warms much faster than the rest of the planet, the equator in particular, the jet streams slow down. And when they slow down, they become wavier. And when they become wavier, they have very powerful, very, very extensive ridges that go high up north. And underneath these ridges, you have high air pressure, and you can have the heat going up into the high Arctic. And then as the wave, you might have 7 nodes as you circumvent the Earth in the jet stream. And in the troughs, the cold air from the Arctic goes very, very far south. And these patterns can kind of get stuck in place and be kind of persistent. The topography on the ground is important, where the mountain ranges are, et cetera. And these jet streams can kind of get stuck. And when they get stuck, you get persistent weather. And yeah, it's you get this more extreme weather. And it's also a similar thing is happening in the southern hemisphere, but you're mostly ocean down there. So I don't think there's other factors coming in. You don't have the topography coming into play. So I think the jet streams are not quite as haywire, if you like, in the southern hemisphere.
Yeah.
But all of these factors are impacting, people eat today, right? And as warming accelerates, these things can happen even more so. And then there's a worry that things like I told you about the reduced natural sequestration of CO2
Yeah.
from the northern hemisphere plant growth, but we're also getting, we're getting concerned about methane coming from wetlands. If lots of the frozen permafrost and tundra thaws in the Arctic region, that can release lots of methane. They're finding methane. I did a recent video on glaciers in Svalbard, and some scientists have been studying the meltwater coming from glaciers in Svalbard, and they've measured methane levels about 800 times higher in the meltwater than in the background in the atmosphere. And they've done an isotopic analysis on the carbon in the CH4, the methane in the meltwater, and found that they call it thermogenic origin. So it's not just organic material under the melting ice that's exposed to air, broken down by bacteria producing methane. It's actually methane that's deep inside the sediments and the rock layers. So when the glacier recedes, the pressure is reduced, you get isostatic rebound of the rock. It happens over a long periods of time, but you can get cracking in the rock, and then you get water seeping in. And when the water runs out from under the glacier, it's got high methane concentration.
Right.
So methane is a big wild card.
Mm.
It's a very powerful greenhouse gas. So we're literally playing with fire on our planet.
Yeah.
And it's getting worse, if anything.
Yeah.
you know um the idea of drill, baby, drill, and just keep going at all speeds with fossil fuels is just it's just asking for trouble. So I mean, I've really been pushing. I have my three-legged bar stool concept,
I like that concept.
which and people often say three-legged stool, and I always correct them. No, no, it's a three-legged bar stool. The bar stool has taller legs, like a
Yeah,
little. It's not like a
and
little
it's and it's
footstool.
wooden. And if you got it the right way around, you got a place to perch your feet on. And if it's not
Yes,
the way
and
around,
you need
fall
for
over.
stability, you need the three
Yeah,
poles, the three legs, and
yeah,
the first one is slashing fossil fuel emissions,
yeah.
right? But then that's what most people just talk about. They don't, we're not doing it, but people talk about it.
I call
But
that
then the next
I call
one,
that euthanize the fossil fuel industry.
yeah. And then anyway, the other leg is greenhouse gas removal,
Yeah,
carbon removal,
drawdown.
and methane removal, and it could be from as simple as repopulating the ocean with the biodiversity that we had, say, 100 years ago.
Yep.
Right, because I think of all the carbon that would be embedded in a plethora of marine creatures, the
Yeah.
whales, et
Beautiful.
cetera,
Yep.
all the way up the level trophic levels of life in the ocean. I mean, that would be a huge way, and
Yeah. Or
and we
seafood.
can't go and cut down every tree in the U.S. as somebody is advocating for, so they don't have to buy Canadian softwood lumber. Um, and so that's the second leg, and then the third leg is the most controversial idea of things like solar radiation management. We know it will work. We know that sulfur in the stratosphere will cool the planet. It happens when a large volcano goes off. So if we wanted to, it wouldn't be that expensive to, say, cool the planet half a degree in 6 months, for example.
Right. Right.
Right. And so the idea of this is to, if things start going haywire, the idea is use this technique to then give us time to slash fossil fuels and to figure out how to sequester more carbon, right? To buy us time. It's not something you'd want to keep doing forever,
Yeah. Yeah.
right? But
Are you you're an advocate of the iron ocean fertilization, the idea of
uh,
microscopic traces of iron as
I
a
think,
stimulant for
yeah,
solar planting?
I think we're on our way rapidly downhill. So I think I think it is a climate emergency, and when you're in an emergency, you have to look at these emergency measures to.
Yeah.
So I think the most effective thing that would be quickest would be sulfur aerosol injection
Right.
into the upper atmosphere. I mean, we who decided to take sulfur out of all of the shipping fuels, right? The International Maritime
Yeah.
Organization did, and
Yeah.
make sure you go and visit James Hansen's. Just Google James Hansen, Columbia University, go to his website and read some of his papers on, over the last year, and you'll really get a good understanding of how sensitive the Earth system is to sulfur,
Yeah.
not just like the sulfur in the shipping fuels goes into the lower atmosphere.
Yeah.
And taking out sulfur, it used to be, 4 or 5% of the fuel. It was very dirty fuel. We used to send the dirtiest fuel to ships to burn
Yeah.
because they're burning it over the ocean. It's away from people. We
Yeah.
thought it would do less harm there. But it turns out the sulfur concentration was 4 or 5%. So they've legislated it down to like 0.1% or something. So there's far fewer sulfur aerosols over the pristine ocean. So they're not blocking sunlight anymore, and they're not generating the low-level clouds. So low-level clouds are way down. This is a huge factor for increasing the Earth energy imbalance, the amount of warming watts per square meter that is warming the Earth. So just in the space of a few short years, we've seen accelerated warming. We've probably set these global temperature records because of this reduction of sulfur in shipping fuels. So all I'm talking about is if you put much less sulfur than is coming out of the ships into the stratosphere and do it properly and carefully, you can cool the planet significantly, to buy us some time to do things that we're not doing yet, like slashing fossil fuels and figuring out how to sequester more carbon. And in fact, as I mentioned, the sequestration of carbon naturally is reducing.
Yeah.
It peaked in
Yeah.
2008 and it's
Yeah.
reducing. So,
Yeah.
it's like a double whammy, if you like. We're being
Yeah.
hit on both ends with this.
So maybe the Starlink satellites, which are just burning up in the mesosphere at a great rate and spreading all of that toxic smoke, is actually kind of helping us in a way. Isn't that going to have the same sort of reflective effect as the sulfur in the stratosphere?
As much as I'd like to agree with that statement about it helping us, um, it is becoming a huge problem. I think 30 or 40% of the Starlink satellites are put in low Earth orbit. So they're only, 140, 150, I don't know,
Yeah.
maybe 180 miles above the Earth. The reason they're put into low Earth orbit is to reduce the lag or latency of the internet,
Right.
right? So that your web page opens more quickly,
Yeah.
right? You have less lag,
Yeah.
and but there's air molecules up there, so there's
Yeah.
friction. So
Yeah.
these satellites, they can boost. They have some mechanism to boost them to maintain their orbit for, but they're good for about 5 years, and then they
Yeah.
have to re-enter.
Then they come back.
They re-enter, so they burn up in the mesosphere, as you say, maybe 40, 50 kilometers high. 30 or 40% of the satellite's aluminum. So when it's re-entering and burning up, it's creating aluminum oxides.
Yeah.
The aluminum, so we're loading up the mesosphere with these aluminum oxides
Yeah.
rapidly.
Yeah.
And gravity pulls that aluminum oxide down over time. And it can take, a decade, 2 decades for the aluminum oxides to come down into the stratosphere and pass through the ozone layer.
Right.
The problem is that aluminum oxide is a catalyst to destroy ozone.
Yeah. Yeah.
Right.
Yeah.
So
Yeah.
what our risk is, and because of the lag, we can load up the mesosphere with aluminum oxide, and then, oh, where's our ozone layer a few decades later? Oh, I guess the satellite aluminum oxide took it out. It came back down to those levels. So that's a problem. That's a huge problem. Of course, people say, well, why do we need the ozone and the ozone layer? Well, we need it so that we can grow plants on the surface of the earth, for one thing.
Well, that's one thing. Yeah. One
Right.
big.
So, yeah, we need it to grow food. We need the ozone to protect us so that we can have plant growth on the surface. Right. So this is going to become a larger and larger issue. It's not really on anybody's radar. There's always a video though. You can Google my name, my YouTube
Yeah.
channel, and
Yeah. Yeah.
ozone,
Yeah.
aluminum oxide. I did 2 videos on this in the last month.
Okay. Good.
In fact, that's probably how you know about it.
I don't know. I don't
You
think
watched
I
my
saw your
video. How did
video.
you hear about it? What?
Oh, look, I've since about 2014, I took a big interest in the ecological impacts of space activity. So I've been coming
Oh, okay.
across
Okay. So,
space
yeah,
activity stuff for a long time, and
yeah, yeah.
and then everyone was cheering because of SpaceX had reusable
Right.
spacecraft, which means you're not dropping the first stage in the ocean, which is a good thing, but it means that the cost
Yes.
of putting toxins in the mesosphere has dropped down considerably.
Yes.
Because
Yes. And
everything that
these,
goes up comes back into the atmosphere.
yes. Yeah. I mean, the Starlinks, I don't know how many do they have up there? 5, 7,000, something like that. They're
Probably
talking about a
1,000.
constellation of 30 or 40,000.
Yeah.
And Google's looking at their own constellation of low Earth orbit satellites, and so is some of the other, like Meta or some of the other
Yeah.
um,
Yeah.
huge billionaire-run
It's
companies.
insane.
Yeah, so we're not very smart, our species, collectively. Individually, we have smart people, but collectively, we're not doing things with any view of their short, medium, or long-term effects, really,
We're
literally.
not behaving as if we want to stay here.
Yeah, yeah, exactly.
Yeah.
And I don't think we can all go to Mars. I don't think that's the solution, really. What we're doing is we're turning our planet into a place like Mars or like Venus,
Yeah.
right? So we don't need to travel to Mars to experience
It might just be perfect
experience the
being Mars
environment
by
there. If we
Earth.
just stay on Earth for long enough, we're going to be experiencing Mars and Venus-like conditions.
Oh man.
The way we're going. And same as if you get bored with your location, you want to see something different. Well, just hang on for a decade or two, and where you live will be totally different, right?
Yeah, or you just burn it.
Yeah, I mean, we'll be growing pineapple trees in Ottawa, you know.
Yeah. Well, actually, global warming in Ottawa may not actually be such a bad idea as far as,
Right.
picture.
Yes, but people love skating on the canal, and we have a canal, and we have a 20 odd kilometer skate. It becomes a 20 or so kilometer skating rink throughout downtown Ottawa,
Right. Wow.
and
Okay.
it's had a very good year. It's been open for, it might have, be open for almost a few months. Last year it wasn't. It was open for about 10 days last winter, and then the winter before it couldn't open all winter because it was so mild.
Oh,
So
wow.
this is the idea, we're getting, and it's funny. I have a funny because, my neighbor had some surgery, not able to shovel snow. We've been getting a snow service to come and clear the snow. And I said, he asked me, he said, so we're going to do the snow service. And I said, global warming, we're not going to get much snow, right? And then he knows me well. So, and he knows my wife. So a week later, he spoke to my wife and as if he hadn't even talked to me. And she said, sure, of course we got to get it. And she wrote him like a check on the spot to share because it's a shared driveway. So anyway, we've had incredible amounts of snow
Oh,
this
right.
winter. So,
Right.
so,
Fantastic.
and one of the problems if it's very, very cold, it's less likely to snow. As the temperature approaches
Okay.
zero,
Right.
it's more
Right.
likely to snow. And so we're definitely warming up, but we're still below zero. So until we pass through,
Yeah.
like it can, one year can be almost no snow, next year can be massive, almost record amounts of snow. So this is part of the weather whiplashing that
Yeah.
I
Okay.
like to talk about. So
So you should do one of your videos with a selfie stick skating on that.
on the
Yeah. Like
I
the
have
full
I
18
have I
kilometers.
yeah, if you go back to early January, I posted a skating video. I did
Okay.
such a thing, but I didn't feel I needed to be in it. I just held the camera
Oh,
facing forward and
yeah.
just skated rapidly, and it's a live action skating video. So
Oh, good
so
stuff.
yes, I've thought of it. I try to get creative with some of my videos.
All right.
So
Okay. Good stuff. All right. Hey, let's that's good place to stop this conversation and with a view to having another conversation because there's so much, Paul.
there is so much. Yeah, we can do
So
this again. Maybe we could do it if you want to do one again in a couple of weeks. Just let me know because
that's great.
we can
Yeah.
discuss. We'll see the information on the storm. Was it
Yeah.
significant damage?
Yeah. Yeah.
Is another one coming along? What
Yeah.
what is your cyclone season in Australia?
Sort of November through to March, really.
November through to March.
Yeah.
Okay.
Yeah. But
Okay.
normally not in Southeast Queensland.
Yes, not yes. So you're nearing the tail end.
Yeah.
So you've gone through the whole alphabet and you're back to A? Like, is this a normal year or is this like
No, we haven't had 26 cyclones this year. They carry on. It's not like one of those
they
accounts with your data where it ends at the end of the month.
oh, and it ends, they just start the next year. They don't
Yeah.
start at A each
Yeah.
year. Okay, so this is different. In the north in the Atlantic, they start at A at the beginning of the season.
I see. Okay.
And
Right.
then they'll go through. They have it all pre-planned what each
Yeah.
let one will be called.
Right.
But then when the season's over, they'll restart
Oh, I
the
see. Okay.
clock
I don't think
at
we have
A
that system over here.
the subsequent year.
Well,
And I'm not sure why do you need an Australian scale, I guess, just to be
well,
different?
look, I that's a good question for a climate scientist, so I might let you get onto that
Well,
one.
that's like a weather question. I don't know.
Yeah. Okay.
I mean, if you haven't used perplexity.ai,
Oh,
just go
okay.
to the website perplexity.ai
Yeah.
and just ask it that question, and it's got usually got very to the point and reasonable answers.
Okay.
So
All right.
I'll have to I'll ask it that when we get off the call, so
Right.
I can tell you next time.
Find out. And look, and
But I don't know. I didn't know they were different, to be honest. So
back to this, there is so many aspects to this polycrisis, metacrisis. My,
yes, there
my
is.
my big
Yep.
interest has been really the planetary boundary stuff, the really foundational stuff that
Yes.
helps maintain the integrity of the planet for life.
Yeah, that sort of,
No,
I mean, they do a lot of work in Sweden at some institutes. Joanne Rockstrom, the planetary
yeah, yeah,
boundaries,
yeah, yeah.
lots of good graphics. The University of Exeter came out with the tipping point report. I think it was just last in January, which talks about the AMOC quite a bit. It's really good report. If you just Google Exeter University climate tipping report, it's very recent, very, very good stuff. I've never been to Australia yet. I'll have to visit at some point. I have an
Don't don't
uncle.
don't come quite just yet.
Yeah.
Don't come to
I have an
Brisbane.
uncle who lived in Melbourne,
Right.
but he's down under now, unfortunately. He's
Actually,
down under, if you
one
know what I
one
mean.
of sorry to hear that. One of the slides that I wanted to share, had I been able to share, was
Yeah.
the spaghetti plots of
Yes.
Cyclone Alfred that actually takes it inland, probably 800 kilometers, and then it does a dogleg and goes straight down to Melbourne, actually.
Yeah, yeah. It's there's some amazing motions of these. I remember a few years ago, Hurricane Sandy, which it was coming down off the US coast, and it did a 270-degree turn and
Wow.
then ended up going right into basically New York and caused tremendous flooding and damage.
Actually, there was,
It was just yeah, it's Hurricane Sandy. So some of
yeah,
the motions of
yeah,
these things are
yeah.
quite amazing. Like hard to predict,
This was a
you know.
question that I wanted to ask, actually,
Yeah.
specifically about Albert. The heat island effect, which is where cities, because of all the tarmac and dark surfaces, tend to get hotter than the surrounding areas. Does that
Yes.
potentially create a kind of vacuum for something like a tropical storm? And I'm not trying to be
Um.
conspiracy-esque, but there is something peculiar
Yeah. Yeah.
about how this
That's a
thing
good
went down and then just did a dogleg straight for the capital, you know?
great. Well, I think it's a big magnet. Personally, somebody's got a big, huge magnet.
Well,
Cyclone
you
magnet.
heard it here
I don't
first.
know. I mean, the heat. That's an
Scientists,
interesting.
you heard it here first.
Yeah, yeah. Well, the heat island. I mean, because you could say, okay, if you've got a city and it's producing huge amounts of heat, the heat is rising, creating this kind of heat dome over the city. The city might be 2 or 3 degrees Celsius warmer than the surrounding countryside, and you have a storm coming.
Mm,
Well, that heat rising creates, the heat rises, it creates sort of a lower pressure
yeah,
where could that pressure suck in a storm? I don't know. Or it's how big would the effect be? That's an interesting question. I don't. I mean, my gut feeling would be, the heat. It could either do that, or it could even repel the storm. Maybe it's like a shield over the city.
right.
I don't know. It's a good question because the heat. You can have very rapid upward movement of air, convection, and it could. I don't think it's going to do much with a massive storm coming.
Yeah,
I think the effect would be kind of secondary,
yeah, okay.
right? So is my sort of best guess, I guess.
Yeah, all right.
I reserve the right to be wrong, so
Yeah,
on that
well,
one. So.
caveat, you know.
So
All right.
maybe we can cover that in our next session.
Yeah, great. I look forward to that, Paul. Thanks so very much.
Yes. Okay. Well, thank you for asking. Thanks for
All right,
having me on. And
all right.
yeah, bye for now.
Talk soon. Bye-bye. Bye-bye.
Okay.
Interrupted cycles, wandering forgotten rhythms and perpetuating skies on carbon.
The feedback's whisper. It's too late, or is it? The Earth system twists in its orbit, human hands carving fault lines in the air, tipping points bleed into each other. A cascade or a symphony, I can't tell anymore. Hot house to hot house, the oceans simmer in their sleep. Hot house to hot house, we write histories in methane and heat. Trajectories slip like ice shells cracking, somewhere the biosphere sighs. Human feedback's the strange puppeteer, governance stumbles in the haze of burning coal. There's a shadow path, stabilized Earth, but it's overgrown, tangled in vines and promises. I dream of carbon sinks blooming like forests, of oceans unweighted by their acid chains. I thought I heard the moon laughing, syzygy tides pulling us towards what the Anthropocene doesn't care about our intentions. It only counts molecules, radii, and forcing degrees. Decarbonize, decarbonize, decarbonize. The mantra sticks in my throat, a synthetic hymn for a world out of time. Hot house to hot house, the oceans simmer in their smoke. Hot house to hot house, we write histories in methane and heat. A cascade or a symphony, I can't tell anymore. Hot house to hot house, hot house to hot house, the oceans simmer in their sleep. Hard to tell, I mean methane and heat. Trajectories slip like ice shells cracking, somewhere the biosphere sighs. Human feedback's the strange puppeteer, governance stumbles in the haze of burning coal. There's a shadow path, stabilized Earth, but it's overgrown, tangled in vines and promises. I dream of carbon sinks blooming like forests, of oceans unweighted by their acid chains. I thought I heard the moon laughing, syzygy tides pulling us towards what the Anthropocene doesn't care about our intentions. It only counts molecules, radii, and forcing degrees. Decarbonize, decarbonize, decarbonize. Thought I heard the moon laughing, syzygy tides pulling us towards what the Anthropocene doesn't care about our intentions. It only counts molecules. We're in the dark, can we rewrite the narrative? Or will the glacial rhythms forget us as we forgot them? Glacial rhythms forget us as we forgot them.